Hey guys, so this is going to be a pretty long video paralleling batteries together, lead acid and lithium iron phosphate. It's really detailed. It has all the charge curves, both batteries by themselves, and then after they're parallel together, discharge and charge curves. It's a lot of details, so it's a lot of talking, a lot of showing stuff, what's going on, pros and cons, stuff like that. So if you just skip ahead, you'll see the results. It's actually works really good. And the only issues is like lead antimony. If you're using those, you have to be cautious with them and cycle them once in a while. Lead calcium, AGM type batteries, those are the ones to use if you're doing this type of stuff. But I cover all this in the video, so hopefully you guys tune in and watch it. Skip ahead if most of the good information about them being parallel together is at the end, well, halfway through or so. So hope you enjoy. Hi guys, so this is going to be a video here about paralleling lead acid and lithium batteries. It's going to be a pretty detailed video with a lot of stuff to cover, like currents and when the currents come out of the battery when they're parallel together, like which ones do the most work, stuff like that, resting currents, do all that, cover it all in this video if I can. But here you can see I topped this battery up at it under a 14.4 volts top up with a 5 amp charge. So right here you can see it's 5 amps going in, hit its voltage, then drop completely down because it was pretty much charged. I only got 2.4 amp hours into it doing that top up. So now I'm going to top up the lead acid battery. I'm going to use this 14 amp hour battery, which is pretty much brand new. It's only been filled and I've used this a lot, so it's definitely in good shape. So I'll be back. Hey guys, here's the quick screenshot of the BMS on that lithium battery, lithium iron phosphate. They're pretty close together. It just came off the charger, so things are gonna rebound a little bit. That's the BMS screenshot. Hey guys, lead acid's all charged up here. Just clicked off not long ago. So I put in 19.5 watt hours. 1.356 amp hours went into it. It was pretty charged. Here's the curve. You can see the current. Here's the bottom one. 5 amp charge. Hit the voltage right away. And it tapered off quite quickly to about an ampere for a bit. Then it cut off at 0.5. Same as the other battery. Lithium. Hey, I've got this one here hooked up. See, it's been resting for a bit. Resting voltage is 13.4. Everything's reset. I'm going to be using the BMS on this one. That's why I have it hooked up right here. Negative is here. Positive is right there. Only these batteries here are in series, equaling 12 volts. This is a totally separate battery, which is not being used at all in this video. It's only these 4 cells. This is the BMS for them. So let's start the test. I'm going to be doing a 2 amp discharge. And it's going to go till it hits 12 volts. Which is 3 volts per cell. I don't want to discharge it too far down, and that's good enough voltage anyway, because a lead acid battery's pretty much dead at 12 volts. So it should work out for the whole test that I want to do. So here's start. It's going to take probably a good 12 hours for this test to run. 11, 10 to 12 hours, I'm thinking. So I'll be back when it's done. You can see here we're at half an hour in and we're still at 13.17 volts with 2 amp draw in the LiPo. I mean lithium iron phosphate. Hey guys, so we're like 4 hours in here now. We're like close to it. Or 2 hours, sorry. 4 amp hours. Very quick. 6 minutes from now. Look, we're still at 13.13 volts. So it just gives you an idea how it's going to work when you have lead acid paralleled with this. So like I've pulled 4 amp hours out of this battery almost so far. It's a 25 amp hour battery. So if you had this paralleled with a lead acid battery, you're still not going to be pulling any power out of the lead acid battery till this one is pretty much dead. Which could be an advantage in some situations though. I'm not saying this is good or bad, I'm just going over everything what would be going on if you parallel them together. And this is one of the things that'll be happening, is the lithium is going to drain first. The LiFePO4. Hey guys, so I'm done discharging this battery. It's been quite a while since it's been finished. So you can see here it shows the amp hours and the voltage and the draw that was on it just by right clicking on the mouse, and I do this. So you can see right here it's 12.6 volts and it's 19.93 amp hours out of the battery, and it's a 25 amp hour battery. So it's dead at this point. By the time it got down here, it was at 21.63 amp hours at 12 volts, 12.025. I clicked off at 12, so where I had the cutoff set to. So if you have these paralleled with the lead acid, your lead acid is going to start pulling the load about here, 12.6 ish. And this 12.6 to 12.4 range is where your lead acid, depending on its state of health, it's probably going to be starting to pick up the load right around here, which could be really good because this is where the lithium is completely dead, pretty much. No matter what size of lithium battery you have, after 3.2 volts per cell is when it tapers off and falls off. Your battery is pretty much dead at 3.2 volts, 12.8 volts if you have a 12 volt battery. So somewhere around here it's pretty much dead. You know, like from here to here there was 3 amp hours left in this battery. From here to there. And then from down here, from here to here, there was 2 amp hours left. You know, so you don't have much left after 3.2 volts. So what I'm gonna do now is I'm gonna discharge the lead acid battery, and we'll get that curve. And then I'll end up charging them both up again. We'll do those curves. And then I'm going to parallel them together. And then we're going to do discharge curve with them parallel together. And then I'll charge them together. And we'll have all those comparisons. and then I'll go over some things that happen with batteries. Like, I'll just show you here on these batteries. These batteries are really good shape. But what you can see with a battery, that's like what's going to happen to your lead acid batteries. These are lead antimony. And this is going to happen. Your positive plate is going to start to bulge up if you're constantly in that 13 and above volt range. Because that's what happened to these batteries. Is I used to use these on my off-grid system, but I don't use them anymore. I have a shitload of lithiums that I use, and they work. Like, since I've put these in, I don't have to baby them. I don't have to do anything to them. They're dusty, but that's about it. These things were just like having kids, or maybe worse. Because, like, as soon as I would go to work, they wouldn't get used enough. Like, they wouldn't get cycled enough, and they were more or less floating all the time. And what happened is they pushed the positive, came up a bit. They're still in really good shape. Like, they have all their capacity and stuff, but you can see how much they've bulged right here. It's because everything swelled in there and they popped up, pushed it up. If you're going to be paralleling lead acid with these lithium iron phosphate batteries, you should be using AGMs or a calcium based battery, because they're made to float all the time. Those lead antimonies need to cycle, and that will happen to your batteries if you do that with them. If you're not cycling them and they're constantly in that float position, that's what's going to happen. Hey guys, so I got the lead acid here all hooked up. It's all ready to go. So I'm going to do a 1 amp discharge on this battery, because it's 14 amp hour battery onto 20 hour rate. So really 0.7 of an amp is what should be its rating. But I'm going to pull 1 amp to 12 volts. And we'll get a discharge curve out of it. I'll be back when it's done. Hey guys, I'm just over a couple hours in here, 2.18 hours. And so when I get down to like 12.35, usually I get about 3 amp hours out of this battery, so it wasn't quite topped up the way I charge it with the 5 amp charge. If you watched the last video, you'll see it, how I charged it. But here's a picture of when I just pulled out it was fully charged this time here. And it's pulled out. It was pulling 1 amp, same as what I'm doing right now. And it came down here, came back up to 12.55, and it stayed there for a long time. And then it's doing the same type of discharge. It's just that for it to get to 12.35, like down here, it's just less, right? Because at this area right here, I had only 1.36 amp hours out of it. Would have been just a little bit of a flatter for a longer time right here. Till it got here, it would be reading about 3 amp hours in this area right here, instead of 1.3, 1.29. That's the only difference you're going to see with this discharge curve. But that's about it. I'll be back when it's set 12 volts. Hey guys, so it's all done here. Got 5.3 amp hours out of it. Brought it down to 12 volts with a 1 amp draw. The curve was pretty good. It's a 14 amp hour battery, and it's in really good shape. Not sulfated at all. It's like brand new condition. So it's, the curve is pretty good, but like once you bring it down a little bit more, probably to about 7-8 amp hour mark, it would drop off a lot. It'd be just like this, just a steady decline. So now I'm going to charge it up. I'm just going to charge it at 1 amp. Bring it up to 14.4 volts. And I'm going to make the cutoff current 200 milliamps. So it should top it up pretty good like that. So I'll be back when that is done. Or maybe I'll do an update halfway through or something. We'll see. Hey guys, so this one just clicked off here. Got 6.352 amp hours. 87 watt hours. Put it in here. Pretty standard charge curve. 1 amp charge. Clicked off at 200 milliamps. So that's it. Took 8 hours and 17 minutes to charge it up. Hey, got the lithium back hooked up here again. Negative here, positive there. 12 volts going through the BMS. So should 2 amp charge, 14.4 volts, 200 milliamp cutoff. Go with that. Probably take over 12 hours to charge it up. I'll be back. Hi guys, so I just got this lithium finished charging here. It's been off for a bit now. But here's the results. So 22.28 amp hours to charge it fully to a 0.2 amp cutoff current, up to 14.4 volts. But you can see here, right there at 12.83 volts, it put 21 amp hours into that battery. I mean at 13.88 volts. So at, let's go to 13.65, which is right here. There's 19 amp hours into the battery already. And it's straight flat here pretty much. So like from 13.13 volts, and even down here is 13.05. That's pretty much flat. Doesn't go up very much. This is why at 13.65 is where I have my absorb limit on my lithium battery banks, my LIFEPO4 battery banks. I don't let the voltage go above 13.65. For a 12 volt cell, my system is 24 volts, so multiply that by 2. That's where I cut it off at, because the battery's pretty much full after that. And bringing it up here is just, you know, you're looking at maybe your BMSs might cut off one cell that's getting too high or something. I don't want to have that happen. So it's just best stop it at 13.65 is where I set that at. So yeah, from 13.65 to full is only another 3 amp hours. But what I'm going to do now here is I got these batteries here. There's one here, and this one's ready right here. I've got the gauge on it. Just have to hook it up to the battery, the negative here to it, right there. And then I need a bus bar here for these. I'm going to join them together. And then there's a center if I need to use it. So I'm going to join them together right away, and I'm going to let them float, like just sit for a bit, and we'll see what type of currents are leaking out of this battery into the lead acid one. The lead acid one's been sitting for the amount of time that this one's been charging for, which is almost 12 hours. So that's what's going to happen now. And then I'll take some readings on the current that's getting leaked over to the lead acid, because that's probably sitting somewhere around 12.9 volts right now. I'll be able to check actually right now. Oh, it's at 13. That's pretty good. But this one's resting at 13.6. So we'll hook them up together and we'll see what that is. And then after that, I'm going to discharge them. And then we'll take readings at like certain hour markers in. How much comes out of this one compared to that one at certain time intervals. You know, like throughout the voltage range down to 12 volts. We'll see where everything changes. Which one starts taking the load. And then we'll charge it up and do the same thing in reverse. Guys, I've got them hooked up here. Everything's hooked up. They're paralleled right here. It's kind of a mess of wiring, but negative connected right there. Just do this right here. Positives are connected together. So now this power you're seeing here is what's coming out of the battery. So which is pretty much nothing, which is a really good thing. Like I said before though, like your battery voltage is going to be always high in here. Especially if you're not bringing your batteries down to like 12 volts. Like if you're just using your batteries regularly, you probably will never come out of the lithium bank. Like if you have a decent sized lithium bank, you're going to notice a huge improvement with your solar system, because these things are so efficient. These things, you're lucky to get, like, when you're charging up one of these batteries, it takes like, I don't know, another from 90% to 100%, which you have to do once in a while with these batteries. It takes a long time to top them up, like almost as long as it does to bulk the battery. So you're wasting all that energy from your system. And like for like having a set of these on your system, it's almost impossible to get them fully charged with sunshine during the daytime. There's just not enough hours in the day to get these batteries full again. That's the problem with them. Like, you know, I got all these lithiums and I have some across on the other side of the wall too. A shitload of batteries. My solar panels charge them up by like 1 o'clock in the afternoon. They're full. You know, so it's like double the size of my solar panels without adding any more solar panels. But like, if you're gonna do this, I recommend using AGMs, like a calcium-based battery, because these lead antimonies need to be cycled. If you don't cycle them, they will be useless. When you need them, they won't work. That's how they are. An AGM is made to sit on float for, like, you could leave an AGM on float for 2 or 3 years and it'll work when you need it. These ones won't. You need to cycle lead antimony batteries. That's why I have this here. It's because I want to keep them in good shape for if I ever do need them. I cycle them. Like, if I'm in here, I'll just cycle them. Because that's what they need. But I'm going to leave this like this for a little bit longer. And then I'm going to start my discharge test. And I'll be back. Hey guys, I've just started the test. It's going to have the same 2 amp discharge to 12 volt cutoff. So here's the battery differences here. So you can see this is one that's taken all the you won't see this one pull any current out of it hardly until this one's almost dead. So it's going to be like 10 hours from now. 8-ish, you might start to see some current come out of this one, but it won't be much. Hey guys, here we are with 10.22 amp hours out of it. Parallel connection. So probably won't see anything come out of the lead acid battery for another couple hours for sure. I think till it gets down to about here. This area. 12.6 volts. So you can see right here. 2 meters. They're probably a couple millivolts difference, because this one's right at 13 volt range, 13.02. That one's probably reading like 12.99. You just can't see it on these gauges. But they've both been on for the whole time. So it says 5 hours 20 minutes, and the graph on the computer says 5 hours 8 minutes. That's because I had this one on and there was power draining out of it into this battery before I started the test. And the clock only starts when there's power being moved in between, or when the power is going through the shunt. This one says 13 minutes and at 7 milliamp hours. So that's whatever was transferring from this battery to that one. And sooner or later it will reverse and this battery will start picking up the load. And then it'll go through this shunt into there. Right now the power's coming through this shunt and going to the negative. So we'll be able to measure it anyway. Some pretty interesting results. Pretty could be pretty handy for certain situations, I guess. The charge curve should be pretty much problem free. I don't see any issues with charging at all. That should charge up normally like any other battery, right to 14.4 volts. And then once it hits its cutoff power, like where you're have your cutoff with your charge controller. When it turns off, then you'll start to see some power from the LiPo just like trickle out of it, just to keep your lead acid in a float charge. Okay guys, so we're 7 hours in, 14 hours, and there's still no power that came out of the lead acid yet. Voltage is 12.96. Okay guys, we're here now, 12.75 volts, almost 19 amp hours, 18.67. It's going to start, well, it has already started. See the lead acid starting to pull some power out of it now, just starting. After 19 amp hours ish, 20 amp hours or so, this one will start to dive pretty hard. I think the charge curve on this one is about 12.65, where it drops pretty hard here. Going steady down like that. But with this lead acid hooked to it, it's gonna just keep on going sideways like that, most likely. So we'll see what happens. Hey guys, so we're at 20 amp hours in, 10 hours down, and this will be the last update till it's actually down to 12 volts. You can see here the lead acid is starting to pick up some of the current. And from here on, they'll start sharing it until it gets to 12. Then I'm going to leave it rest, and then I'll charge it with 3 amps. And it should... both of the batteries will share that 3 amps until they're charged. Should be a pretty normal charge curve, I'm expecting. I've never done this before, but we'll see. Well, here we go, it's all done. Pretty nice discharge curve, if I say so. The lithium iron phosphate would have went just like straight down here without the lead acid being in it. I don't think the lead acid was charged up completely, but that's fine. Still got 4.36 amp hours out of it. $21.9 out of this one. So take a look here. Let's get more focus. $21. To 26.7 from here. So yeah, that was pretty much all lead acid in here. Well, worked out alright. Change this up to charge it. Gonna charge at 3 amps.
same voltage and cutoff. 14.4. milliamps. We'll start, I'm pretty sure. Actually, save this here quickly. Save a picture of it. Should be good. So I think the charge curve is going to be where both batteries are pulling, accepting current the whole way through. It looks like that right now already. Shit, I should have reset these. There, they're reset. So it's pulling over 2 amps. So it's not quite even an amp. 540 milliamps. This goes by the internal resistance of the batteries, that's all. I'll leave that charge and I'll be back. Hey guys, so it's all done. So it put in 27.5 amp hours, 372 watt hours. That's the curve charge. There and down to here, and then it went off. So here's the difference. This meter always does this shit here. 4.9 amp hours back in on this one. You can see that it's trying to leak over from here to there. It's trying to put battery current back in from the lithium iron phosphate into the lead acid right now. This one's trying to go down, that one's staying where it is. And this one got 22.3 amp hours. And it took 9 hours 41 minutes. Charge it back up. 3 amps. So, well, there's nothing really, like, it's pretty equal. The charge curve is pretty much the same as what we are, like, just with the lithium iron phosphate. I think it's pretty close. You know, like, if you're gonna do this, all I say is, if you don't have AGMs or sealed batteries, I'd recommend keeping them far apart from each other, like these in a sealed container that has gases going outside. And these ones you don't have to worry about because the corrosion will cause issues with the terminals if you leave them like that. And another thing with the lead antimony, make sure you cycle them. Wouldn't hurt to do it at least once a week. Minimal once a month. Like if you're gonna do this, I'd say use lead calcium. That's any battery that is a AGM or a sealed, like a non-maintenance type battery. Those are calcium based. These flooded serviceable ones are usually antimony, lead antimony. They're different chemistry. But thanks for watching, guys. That's it for this one. It's kind of a long video, but there's lots of stuff to cover, so appreciate you guys watching.